All right, question 1 is asking about the amount of exercise that student with ID number 2 reported in the survey. And so the first thing we're going to do is find student number 2, and that would be right here on the left-hand side. So all of the values in this row belong to student number 2. Okay, so I'm just going to highlight that right here. And then, of course, the question's asking about exercise. So the exercise variable is right here. And we see that the value for student 2 is 0 hours of exercise per week. This question is asking about which one of these variables is a continuous variable. And the answer, of course, is age at first birth. This is the only continuous variable in the list. Favorite fruit, gender, and occupation are all categorical variables. Okay, these are nominal variables because they're classifying responses into different categories. Decade of birth is an ordinal variable because it is categorizing with an order. That is, there's a relationship between each subsequent group, and so we call that a an ordinal variable. This next question is asking us about to pick the categorical variable, and specifically the nominal variable, as opposed to the ordinal variable. Okay, so a nominal variable does not have an order inherent to it, whereas an ordinal variable does. And so, of course, the answer here is favorite fruit. Okay, so strawberries, bananas, oranges, these don't have an order to them, and so they can be considered, or rather, this favorite fruit category can be considered a nominal variable. Now, if the question had asked you which one was an ordinal variable, you would pick decade of birth, because decade of birth would categorize you into different buckets, but these buckets would have a relationship. They would be in a certain order, and so that would be an ordinal variable. BMI, age at first birth, and height, of course, would be categorized as continuous variables, and that's due to the nature of the responses for each of those choices. This question shows us a histogram for pulse rates, and it's specifically asking us what percent of subjects had pulses between 80 and 90%, or excuse me, 80 and 90 beats per minute. And so we're gonna look at the histogram, right? And we're gonna think about the cumulative percentage between 80, which is right here, and 90, which is about here. Okay, it's halfway between 80 and 100. And so we're going to ballpark this. Because these are all basically below 10, and these look like they might be even below 5, you can make an educated guess and say that the closest answer to this is E, 10%. It's definitely not 200%, 100%, 90%, and it's probably not 50% just because 13.3 is up here. And so if you can imagine stacking this bar on top of here and all these small bars on top and not even really reaching that 13.3%. As review, I'd just like to point out that this is a left skewed distribution. So a left skewed distribution means that the mean is going to be less than the median, right? So the mean is going to fall somewhere around here. The median is probably going to be somewhere around here. This question shows us another histogram. This histogram shows the percentage of students in buckets of sleep hours per night. So the statistical program binned the number of sleep hours per night into these categories for us. And so let's take a look at the question. So it's asking us to pick the true statement. A is asking, or A is stating, more than half of the students slept 7 hours per night. Looking quickly at the diagram, we see that so more than 7 hours would be everything to the right of this line, and that's not more than 50%, so we know A is not true. B states more than half of the students slept between 6.5 and 7.5 hours per night, and so that category of students is actually just this bar, okay, and that is above 50, and so B here is the correct answer. But let's go through the rest of the answer choices just to make sure that they are also false. Okay, so C reads at least one student slept 10 or more hours per night. There's no one in the 10 category, so we know that's false. D reads 25% of students slept 6 hours or fewer per night. Looking at 6 or fewer, we see that it would be this percentage plus this percentage. So right here, these two blocks together would need to reach somewhere around here. And sort of visually, by visual inspection, we see that that's not true. So this question gives us a list of numbers and asks us to calculate the median value within this set of numbers, this set of 20 numbers. So this is one of those tedious problems where you have to actually order the numbers the right way in order to calculate the median value. So that's what I'm going to do first. So I'm going to write this at the bottom here. I'm actually going to stop there. So let's think about this. So there are 20 numbers, and so the median value is going to be between number 10, the average of number 10, so like number 10 and number 11. So this is going to equal the median, and I know that because there are 20 numbers here. So I just need to figure out what the 10th and 11th numbers are and calculate their average. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, and 11. And so the average, of course, of -12 and -14 is going to be -13. So the median value in this set of numbers is -13. So this question is asking us about left skewed data, and it's asking us to pick the true statement. So as review, left skewed data would look something like this, where the tail on the left-hand side is a lot longer. And what this is going to do to the distribution is it's going to shift the mean to the left. Okay, the mean is going to go left. So the mean might be somewhere around here. The median might be somewhere around here. And just for completeness sake, the mode would be at the top of the histogram, the distribution of the histogram. And so which statement accurately captures this relationship? Well, that's going to be statement D, where the median is going to be greater than the mean. So one trick when remembering, when trying to remember left skewed, right skewed, and stuff like that, is to remember this exact relationship. If it's left skewed, the median is to the left, the mean is to the left of the median. And if it's right skewed, the mean is to the right of the median. Okay, so you can think about it as describing the relationship between the mean and the median. And then you'll be able to sort of intuitively imagine the distribution in your head to answer these questions. This question is asking us to calculate the standard deviation of the following numbers that we have in our data set and to round our final answer to the nearest whole number. And so the first step is to remember what the formula for the standard deviation is. And so I'll start off by writing that out. So that is SD for standard deviation equals the square root of the sum on top, that's an I there, of x sub I minus the mean squared over n minus 1. Okay, so that looks complicated, but basically we need to figure out two things in order to calculate this formula. We need to figure out what n is and what this x bar is. X bar is the average. So first things first, so n is probably easiest. So n is just the number of numbers, I guess, in our data set. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 10. Okay, so n is 10. And then we can calculate the average here. So that's just going to be 4 plus 3 plus 0 plus ... all the way to -300 divided by n, or 10. Same thing. And that's going to work itself out to be -34.5. So here we have the average and we have n. So what we can do is replace these in the formula. And so I'm going to write this in. So n is now 10. And so it's x minus negative 34.5, but that's the same thing as x sub I plus 34.5. So you might be wondering to yourself, what is this x sub I? What is this summation doing here? I think the easiest way to explain it is to write out the first few terms here. Okay, so what is this saying? So it's saying we'll take the first number in your data set when I equals 1, so that's going to be 4, and then add 34.5, square that, okay, and because this is a summation, okay, because we're summing this expression, what we're going to do is we're going to add, and then we're going to move on to the next number in our data set, which is going to be 3. Okay, you can imagine I being equal to 2 now. So x sub 2, or 3 plus 34.5 squared, plus, again, because of the summation, 0 plus 34.5 squared. Okay, and we're going to do that all the way until negative 300 plus 34.5 squared. Okay. And so that takes care of the numerator. And then on the bottom, we're just going to have 10 minus 1, which is 9. And if we do this all out, that is going to equal 94. And so the answer to this question is A, 94. So in this question, we're asked to calculate the standard deviation again and round our final answer to the nearest whole number. Okay, so it's very similar. It's the same thing as the last question, so it's good practice for us. So once again, the first step is to write out the formula for the standard deviation, and that hasn't changed since last time. So that's going to be the square root of the sum of x sub I minus the average squared over n minus 1. And so once again, we need to know two things. We need to know n, and we need to know the average. So n here is going to be, I have a feeling it's going to be 10 again. 6, 9, 10. Yeah. So n is 10. And I got that just by counting the numbers here. And then the average is going to be negative 8 plus negative 10, etc. until negative 30 divided by 10. Okay, and the average this time is going to equal negative 18.5. So now that we have these two values, once again, we can rewrite our formula by substituting those numbers in. So again, this is just going to be the same thing as adding 18.5 here. So I'm going to write the first few terms once again. So this is going to be negative 8 plus 18.5 squared plus negative 10 plus 18.5 squared all the way to the last number in our data set. Let me just drag that over. All divided by 9. Okay, and the standard deviation in this case is going to equal 7. So the answer to this problem is E7. This question asks us to calculate the interquartile range given the following data points. The first thing you should notice is that the data is arranged for us. It's already sorted in descending order, which is great because that means we don't have to do that. That would otherwise be the first step. So now what are we going to do? Well, our approach to these types of problems is going to be to first find the median, okay, which represents the 50th percentile. And then, let's say that's the edge of our data set, and that's the edge of our data set. And then to find the middle, okay, so that's going to be the 75th percentile, and then to move this way to find the middle, the median, essentially between here and here, to find the 25th percentile. Okay, great. And of course, we're doing that because the interquartile range is defined as the value at the 75th percentile minus the value at the 25th percentile. So let's take a look at the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, always 10. So there's 10 values here, which means that the median is going to be the average of negative 4, negative 5. So the median is going to be negative 4.5, but that's less important right now. What's more important is to sort of visualize this sort of middle 50th percentile line here, right? And what we're going to do is we're going to move left starting here. We're going to move right starting here. We're going to move left starting here to find the middle value, the median of this subset of numbers, and that's going to be -14. Doing the same thing here, the median is going to be 0 within that subset. Okay, and what that's going to allow us to do is to say that, okay, this is the 75th percentile, this is the 25th percentile, the IQR is simply 0 minus -14 or 14. So the answer to this question is C, 14. This question asks us to select the statistical measure that does not describe the spread of the data. Our choices are the variance, the interquartile range, the standard deviation, the range, and the mean. So of these choices, the mean is the only choice that does not describe the spread of the data. All the other choices, the variance, the IQR, the standard deviation, and the range, all give some kind of information about the distribution of the data and how it's spread out. The mean is a summary statistic, so it does not give us any information about the spread. This last question is asking us to choose the statistical measure that is not influenced by outliers. Our choices are the variance, the interquartile range, the standard deviation, the range, and the mean. The only value here that is not influenced by outliers is the interquartile range. Okay, the variance, the standard deviation, the range, and the mean will all be affected. Let's say if you change one of your numbers, one of the values in your data set from something like 30 to 300. You can imagine that all those statistical measures are going to be affected in some way. Now, the interquartile range in this situation is not going to be affected if 30 is, let's say, already above the 75th percentile. Let's say 30 is in the 80th percentile in your data, and you change that 30 to 300, okay? Well, that's not going to affect the calculation of the interquartile range, because that's only the 75th percentile minus the 25th percentile. It does not change what those numbers are. Okay, so another way of phrasing this, or another way of thinking about this, is that the interquartile range is more dependent on how the numbers in your data set are ranked. And the other values, the other statistical measures presented here are more dependent on the magnitude of the values in your data set.